Right, today in geometry, we are looking at area of composite shapes. So remember, we have the area addition postulate that says if a figure is composed of two or more parts that do not overlap each other, then the area of the figure is the sum of the areas of the parts. So we want to find the area of each of these. Number one, I look at the shape. It's not any known shape, but I see that I can recognize a rectangle and a triangle. So I'm going to find the area of the rectangle and the area of the triangle. And then I'll just add the two together. They tell me up here AB is 10, BC is 3, EC is 4, and angle C is 90. Okay? So the very first thing I need to do is find B to E, right? I see that this is a right triangle, 3, 4. I'm looking for the hypotenuse. It's a triple. If I didn't recognize the triple, I would do 3 squared plus 4 squared equals x squared. But it's a 3, 4, 5. So now the area of the rectangle, length times width. So 10 times 5, which is 50. Area of the triangle, it's a right triangle, so it's 1/2 the base and the height. Remember, base and height have to be perpendicular. So 1/2, 3 times 4. So 4 times 3 is 12. Half of 12 is 6. So now add those two together, and the total area, 50 plus 6 is 56. My units were centimeters, so square centimeters. That's the first one. Number 2, again, this is not any shape that we recognize right off the bat. So I can, again, do area of rectangle, area of the triangle. So the rectangle is 13.4 times its height, 12.5. So when I multiply those, let's see, I get 167.5. The area of the triangle, again, this is 10. The height is 12.5. So 1/2, 10 times 12.5. So half of 10 is 5 times 12.5. 62.5 square meters. Add them together. So my total area is 230 square meters. Number 3, again, not a shape that we know, right? So can I separate this? I could separate it this way, right? Or I could separate it this way. It doesn't matter which way, okay? So I'll just leave it like this. This is how I have it. So I have a rectangle up top and a square down here. The area of the rectangle, the base times the height. So 6 times 2, which is going to give me 12 square feet. The area of the square now, so the square, so again, that part is 2, this is 3, so 3 times 3 is 9 square feet. The total area, add those two together, so 12 plus 9 is 21 square feet. All right, next page. Back here again, looking at the shape, it's not anything that I recognize, but I can divide it into 3 shapes, right? So this first shape here, 6 times 4, that's going to get me 24 for that area. This one, again, 6 times 4, 24. So here, okay, this whole thing is 4 units. Up here is 2, so this is 2. So this whole thing is also 4. So 4 times 2 is 8. So the total area, 24 plus 24 plus 8. So 24 plus 24 gets me 48. 48 plus 8 gets me 56 square units. I look at number 5. Number 5 looks like I have a trapezoid here, right? So This entire base down here is 17. The top base is 12. So area of a trapezoid, 1/2 the height. So this height is the same as that 12 times base 1, 17, plus base 2, 12. So half of 12 is 6. 17 plus 12 is 29. So 6 times 29 is 174 square meters. I not recognize this as a trapezoid. I could have found the area of the rectangle, or in this case a square, and then the area of the triangle, and then add those two together. So now it says find the area of the shaded region. There are several different ways that I could work this. I could find the area of the entire thing, and then the area of what's not shaded and subtract it out. Or I see that the area of the shaded, they're all marked the same. They're triangles. So if I find the area of one triangle, that's 1/2 the base, 6, times the height, 6. So half of 6 is 3. 3 times 6 is 18. But now I have 1, 2, 3, 4 of those. So the area shaded is going to be 4 times 18. So 18 times 4 gets me 72 square units. All right, next page. It says what length of fencing is needed to surround this yard. Okay, so again, I look at what shape do I have. Okay? This looks again like a trapezoid, right? Top base, bottom base, height. So what length of fencing is needed to surround the yard? So this surround, that's perimeter. So I'm looking for perimeter here. I need this side first. I can make a triangle out of that, right? Right triangle. I know this is 16. If this part is 11, the whole thing was 18. So 18 minus 11, that leaves me with 7 up there. So Pythagorean theorem to get my x. So x squared equals 7 squared plus 16 squared. X squared equals 49 plus 256. So add these two together, and I get x squared is 305. Take the square root. So x is equal to the square root of 305. What length of fencing? So now I want the perimeter. So I'm going to add them all up. 11 plus 16 plus 18 plus the square root of 305. And since I'm going to round the square root of 305, I'm going to say the perimeter is approximately. So I'm going to add all of those up. And I say that the perimeter is approximately 62.5 meters. It says the cost of fencing is $2.50 per meter. How much will it cost to enclose the yard with the fence? Well, I need 62.5 meters of fence. It costs $2.50 per meter. So I'm simply going to multiply those two together. So 62.5 times 250 gives me $156.25. Now it says you want to cover the yard with new grass seed. How much grass seed do you need? So if I'm covering all of this, that means I need area. So area, again, we said it was a trapezoid, 1/2. The height of this trapezoid is 16. Times the two bases added together, so 11 plus 18. This is half of 16 is 8. 11 plus 18, 29. So 8 times 29 gets me 232 square meters of grass seed. Now it tells me that grass seed costs 57 cents per square meter. How much will it cost to cover the yard? I need 232 square meters. It costs 57 cents a square meter. Multiply those two together, and it's going to cost $132.24 to cover the yard in grass seed. All right, so that is all of the area of composite shapes notes. Your homework is the area of composite shape worksheet.